Hello, I'm Mr. Franklin, and today we're going to look at gas stoichiometry. Now, a while back we did stoichiometry, and we got to remember that stoichiometry is just the way that we take our recipe, our chemical reaction, and we can tell how much of an ingredient we're using or how much of a product we're going to produce. And we can calculate and figure that out because we have a balanced equation which acts like a recipe and tells me what we're going to produce. Now, that's what we've done. Now we're taking it and we're going to look at gas stoichiometry and going to be able to look at some things, because if a chemical is in its gaseous state, there are some things that are always considered to be true. So first, by way of review, when we first started this, we learned that 1 mole of hydrogen gas, H2, because it comes in pairs, is equal to, remember we calculate the molar mass for the triangle, so we took H, there's 2 of them, multiplied it times the atomic mass on the periodic table, so 2 times 1.008 equals 2.016 grams, okay? And then we put it on this corner of the triangle just to show us that 1 mole of H2 is equal to 2.016 grams of H2, which is also equal to Avogadro's number, which is that 6.022 times 10 to the 23rd molecules in this case. And we had all these things that are equal to each other. Now, when we are dealing with the gas or something else, and this is really what Avogadro figured out for us, and that is, because this is where he started before we figured out all this other stuff with the grams, is he started with gases and with volumes. And what he discovered was that 1 mole of a gas is equal to 22.4 liters of that gas. So 1 mole of H2 is equal to 22.4 liters of H2, which is equal to Avogadro's number, which also is equal to that mass. Because if this is equal to moles, then it's also equal to that many grams. So if I have 2.016 grams of H2, I will have 22.4 liters of H2. If I had 18.015 grams of H2O, water, or which is 1 mole of H2O, guess what? I have 22.4 liters of H2O. Now, there's a gotcha with that, and that is this. This is true as long as we're under the conditions of standard temperature and pressure. So we haven't talked about this really yet, but standard temperature and pressure says that the temperature is 0 degrees Celsius and the pressure is at 1 atmosphere. Basically simulating the conditions at sea level is what that does. And if we were to convert that to Kelvin, we would get 273.15 Kelvin. Now, it's interesting because we are going to convert it to Kelvin, but most textbooks and most people, when they talk about STP, they're going to talk about it in terms of degrees Celsius, 0 degrees Celsius and 1 atmosphere. Okay? So now that we understand this, now we're going to actually apply it to a couple of situations by using our dimensional analysis line to solve some problems. Okay? So let's try one. So we have this problem here, and it says 3 grams of hydrogen is how much I have in a container. What volume of H2 is that going to occupy at STP? So the first thing you would do, anytime you do this, is you would do the triangle, right? So 1 mole is equal to 22.4 liters, but that's also equal to the molar mass, right? And the molar mass of hydrogen is there's 2 hydrogens times 1.008, 2.016 grams. So on the triangle, this is equal to 2.016 grams of H2. So 22.4 liters of H2 is equal to 2.016 grams of H2. Let me say that again because I said it fast. 22.4 liters of H2 is equal to 2.016 grams of H2. Okay? So now that I know my conversion factor, I can do the dimensional analysis line. So we start with 3 grams of H2. So what's the next step? Whatever I have my units has to go down here. So grams of H2, grams of H2. But what am I converting it to? Normally we would put moles here, right? But we don't want moles. What do we want? We want, use the eraser here. We want liters. So our liters of H2. So we're going from grams to grams, convert it to liters. Now I'm going to plug in my numbers. So the numbers say 2.016 grams and 22.4 liters. Grams H2 cancels to 1. 3 times 1 is 3. 3 times 22.4 is 67.2 liters of H2 divided by 2.016, which is equal to, let me pull out my calculator. Okay, calculator. $67.2 divided by 2.016 equals 33.33. 33.33 liters of H2. Assuming that all the other conditions are the same. Okay? Pretty simple. So now what I want you to do is go ahead and practice a couple of these problems on your paper and just convert from grams to liters.